Let's look at a couple of problems from section 4.3. These are practice problems, and I'm looking at the far left to start. And the first thing to keep in mind on this problem, log of 5x plus 20 equals 2, is that there is no base written. And when there's no base written, then it means that the base is a 10. And what we're going to do is we're going to convert this logarithm to an exponential. And I like to call it the curly Q when we do these problems. So I kind of curl around, kind of make a spiral. So converting this means 10 squared equals 5x plus 20. And once we have that, now it's just going to be mostly a basic algebra 1 equation. 10 squared is 100. And then we're going to solve. We can subtract 20 from both sides. We get 80 equals 5x, and divide both sides by 5. So x equals 16. As we look to the right here on our problem, it's almost the same. Again, there's no base written, and when you see the word log, which is abbreviation for a common logarithm, the base is 10. But before we can actually do the curly Q, what we need to do is we need to isolate the logarithm. So we're going to divide both sides by 2. So this is going to be log base 10 of x plus 86 equals 2. And now that we have that, then we're going to use the curly Q again. So we're going to take this value of 10 and we're going to spiral around. So it's going to be 10 squared equals x plus 86, and 10 squared is 100 equals x plus 86. Subtract 86 from both sides, and we get 14 equals x. So now I'm back to the left of the paper, and we're going to use the logarithmic properties for the starting process. And the first thing to notice is that there's a 2 out here in front of the logarithm, so we're going to make it an exponent. So this is going to be log base 8 of 16 plus log base 8 of x squared equals 2. And when we apply the second property to it, the second property is coming from the fact that there's a plus in front of this logarithm. And plus says that because the bases are the same, we can rewrite this as 16x squared equals 2. And now in this format here, what's going to happen is we're going to curly Q again. We're going to convert this logarithm to an exponential. So we're going to spiral. So it's going to become 8 squared equals 16x squared. No more logarithm to deal with, and we can solve this. And 8 squared is 64 equals 16x squared. If we divide both sides by 16, we get x squared equals 4. Got to be able to see it. So I did 8 squared equals 64, divided both sides by 16 to get the 4. And then since it's x squared equals 4, the inverse operation is going to be to take the square root. And if you want to get technical, this is plus or minus 2 when you solve that. But if you've looked at the tutorial, what happens is it talks about extraneous solutions. So our two choices here are x equals 2 and x equals negative 2. And what has to happen is when you go back to the original problem, what I call the number part of the logarithm, which is where the 16 is located, that value has to be positive every single time. So what we specifically are going to look at is this x here, because that's the number part of the logarithm. That value must be positive. So when we go back and check our answers and we put the 2, the positive 2 back in there, positive, but x equals negative 2 will give us a negative in for this x, which means that x equals negative 2 is extraneous. It means that it looks like it's a perfectly good answer, but when you put it back into the problem, it won't work. If you type 2 log base 8 of negative 2 into your calculator, you will get an error.